there's a lot from my astronomy career that's helped me in my data science career to the point where it almost doesn't feel like two separate careers sometimes. It does feel like a lot of the skills that I cultivated over the course of a decade and then before that in undergrad that became almost you know seamlessly applicable to my life in data science. And if you had told me 6 years ago as I was leaving academia that, oh yeah, you're gonna be leading a team at a company, you're gonna be an executive and you're gonna be working with uh, AI algorithms and computer vision. I could not have imagined that, but here we are.
Welcome, listeners, to our first episode of Astronomers Turned Data Scientists, the show where we explore the fascinating journeys of individuals who've bridged the cosmic realms of astronomy with the data-driven universe of data science. I'm Joseph Ahern, in my second year of being a data scientist.
And I'm Jeff Silverman. Been a data scientist for about 7 years now.
And we are the co-hosts for these first episodes of Astronomers Turned Data Scientists.
Our guest today is Taka Tanaka, who is an astronomer turned data scientist. He's been a professional data scientist for the past 7 years, currently working at Rock 360. Welcome, Taka.
Well, welcome to Taka. Thanks for coming on our podcast. And we know that you've been coming to our Astronomers Turned Data Scientist meetings every year and speaking at them. So we thought that...
How many years has it been?
Has it been 5?
The first one was 2019, AAS, January 2019.
Oh my goodness.
So I think you've been to all but one, Taka, if I recall.
I think I might have attended everyone or at least given a talk at everyone. So that's
nice.
5 out of 5. I think.
Awesome. So as someone who's been a solid member of our Astronomers Turned Data Scientists community, we thought you'd be a great first guest for our podcast.
I'm so honored. I didn't realize that I was the first one.
Yeah, we know exactly what we're doing. It's the first shot. We're going to get it perfect, so nobody worry.
All right, great.
Yeah. So, of course, we'll be talking about your transition from astronomy to data science. But first, just to get an idea of what you were doing in astronomy, what first drew you in, and what sorts of research did you go into astronomy to do?
Yeah, I fell in love with astrophysics toward the latter half of my undergrad. I took a bunch of graduate courses. I had the good fortune of taking courses from people like Dr. York, Dr. Tukolsky. I had, such a good time, like solving abstract questions, doing order of magnitude estimates. The topic itself, I mean, who doesn't love it, right? It's the kind of stuff that sucks you in, and I studied black holes, no pun intended. And then I went on to do my first attempt at a PhD at UPenn. I left after a year for personal reasons. There wasn't really a great fit with the program there. And then I worked a bunch of odd jobs for about a year. And then I made my way back into academia working part-time with Kristen Manu at Columbia. And then after that, I joined Columbia officially as a graduate student, and then I eventually got my PhD there. I had 2 thesis advisors, Kristen Manu and Zoltan Hyman. It was a really great time, very supportive department. And then I did 2 postdocs, one at the Max Planck Institute for Astrophysics in Munich. I worked with Dr. Snyaev there. And then my second postdoc, I worked with Rosalba Perna and Andrew McFadden jointly at Stony Brook and NYU. So I was, doing grad school and postdocs. I was a professional astrophysicist for a bit over a decade. And then, going to my transition, I basically hit a brick wall. I was like burned out, kind of my mind just couldn't concentrate anymore. I was dealing with some personal problems that made it really hard to balance personal life with work, especially with all the stresses and pressure to publish and to apply for jobs. And I got sick of moving. It's just like it was really draining for me to not know where I was going to be a year or two from now. And I said, maybe there's some other option out there where I get to do intellectually interesting things as a part of my day-to-day and then make a living and not have to be at the mercy of kind of this job application system. And maybe there's things I can do outside of permanent jobs in academia to have some sort of stability. And I think I'll touch on stability and like different kinds of stability later in this episode, I guess. But yeah, that's kind of where I was at. And then I was fortunate enough to be able to participate in the Insight Data Science program in New York. And yeah, that's how I landed my first data science job. And that was in the winter of 2016 to 2017.
So thinking back, 2016, 2017, that was around when I made the transition as well. And it feels like forever ago now. It's not that many years, but it's, approximately the length of a PhD at this point in time. So, remembering back to those days, what was your mindset? You talked a little bit about reasons for wanting to leave academia or places, reasons to move on, but, sort of what were you thinking about going into data science, the tech industry, both positives and negatives, right? We've heard from a lot of people about they're excited and it sounds cool and they've heard some great things, but there's imposter syndrome. There's, the fear of moving out of academia that you've been in for however many years or decades.
Absolutely. I think it was a combination of despair, relief, and excitement. At first,
I love that combo.
Yeah. At first, so before I got into the Insight program, and for those of you who don't know what that is, it's basically like a couple of months long kind of boot camp to study data science topics with other people, mostly coming out of PhDs or postdocs. And then the program basically helps to place you with a data science job with various companies that are looking to hire. Unfortunately, they've been inactive for a couple of years, but there's several boot camps like it. So before I had got into that boot camp program, I didn't know what I was doing. I had no idea what kind of jobs were out there. I had very little to do with, I had very little knowledge of the lay of the land. At the same time, I was kind of relieved that I was out of the grind. I didn't have to apply for academic jobs anymore. It's like I was done with that. A little bit of bittersweet. I think at that point I was pretty, after doing it for a decade, I had to get used to the idea that this is now, right, a non-job for me. It's something that I know a lot about, but I am no longer it's not going to be a part of my career going forward. That didn't happen to be entirely true. But yeah, that's what was going on. And then once I started the boot camp, after I got into it, after I had met other people in my cohort that were also looking for data science jobs, some people out of physics, some people out of math PhDs or social sciences, all sorts of fields. That's when the excitement kind of started to grow. It's like, oh, there's so much cool things out there. There's so much fun ways to solve problems and so many different ways to think about solving problems. And those things, I think for academics, that's kind of what you love to do, right? Like learn about new ways of thinking, find out about new ways to solve problems. And so being able to get exposure to that as a part of that boot camp was really a great kind of springboard for me, where I could really kind of jumpstart my enthusiasm for data science out in the wild.
Do you think there are any specific skills from your astronomy, astrophysics background that have given you a unique perspective in data science? Like maybe some things that other data scientists that didn't have the astronomy background don't have?
there's a lot from my astronomy career that's helped me in my data science career to the point where it almost doesn't feel like two separate careers sometimes. It does feel like a lot of the skills that I cultivated over the course of a decade and then before that in undergrad that became almost, you know, seamlessly applicable to my life in data science. And one thing that sticks out is the ability to deal with ambiguity and complexity. And if you're doing any sort of social science or physical science at the PhD level, it's full of unanswered questions. It's full of limited data or limitations data, selection biases, who wrote the paper and what was their agenda, what did they want, what was the message that they wanted to convey. And you think about all of these things, think about statistical significance, almost like it's second nature. And those are things that people coming out of undergrad or even masters in data science programs in their, so let's say mid 20s, those are things that people don't often have, that if you've been in academia, you've had the privilege to think about, things in a rigorous scientific way for a long time. So that's one thing that I take advantage of a lot in my data science life. Um, Another one is communication. If you've done public talks, I think most academics have teaching experience, TAing classes or sitting in recitation sections and things like that. Writing papers or trying to express your scientific findings in like an intelligible, coherent way. All of these things are really useful in, both team meetings as well as boardrooms as well. Being able to talk about the core of your findings and what you want to communicate about them to either a room full of people that maybe they're teammates and that aren't working on the same project as you. So very much like going to a seminar in astronomy, or to a group of executives who only have a high level understanding of data science and the algorithms that you're using, but have a great, have a lot invested in the outcomes and the business applications of your work. So being able to communicate to both of those different groups has also been something that I got, that I was able to carry over from my career in astronomy. And then things like interacting with peers, right? How do you manage collaborations? How do you, if you're mentoring a student, if you're working with a postdoc that might be more senior than you, if you're working with a junior professor or senior professor, how do you navigate communicating progress, communicating when you're stuck? How do you navigate when there's intellectual disagreement about the approach? All of those things, were, I think, if you've done a PhD in any field, you're pretty well seasoned by the end of your PhD in navigating those relationships. And that's very important too.
So a lot of the stuff that you talked about, lots of positives about, the tech industry. Of course, nothing is perfect. There's, flaws and concerns and challenges everywhere. I think there's a whole chunk of the podcast we could spend on sort of, your current state of what you're doing and what you're concerned about, both, for your group, your team, your company, and maybe the future of tech and data science. But I think the first thing I want to get to is, again, sort of starting off, making that transition. Once you made it, once you got that first job in industry as a data scientist, what were, maybe the one or two biggest challenges that you encountered, that maybe surprised you, maybe you kind of were prepared for it, but were still, kind of a challenge that you had to overcome as a brand new data scientist, even though you've been using a lot of those skills as an academic astronomy researcher?
Yeah, I think a major challenge is learning the tech stack. And I think that's an even steeper learning curve today than it was 5, 6 years ago when I was starting. Um, you know, I can go through like a Greek alphabet soup of all the different technologies that are kind of, if you work in tech, then you would probably have an idea of what they are, even if you don't use them on a day-to-day basis. But if you're a PhD student in astronomy, it just sounds like a foreign language to you. And I think that's an an even more of a hurdle today. So like things like Docker, AWS, GCS, or GCP, S3, Prefect, Airflow, it's Kubernetes. It's like there's this sea of there's this own jargon, right? It's like if you are, taking your first graduate level course, and people are talking about hard X-rays and soft X-rays and type 1 and 2 AGNs and right supernovae and kilonovae and this type of dwarf and that kind of dwarf. It's just it feels overwhelming at first, and then if you're in a PhD, you have several years to kind of get to that point and build that jargon up so that you can pass your qualifying exam or write your first paper. In the industry, the rest of your team is running with it. You might not need to know it your first day, but in a lot of cases, you have to know the jargon that's relevant to you in a couple of months' time. And I think that's hard. And what I think is even more challenging is a lot of jobs want you to have it the day you start, or want you to at least know what these things are the day you start. And that's a definite barrier to entry, I feel.
Yeah, I mean, I think not only just the tooling and the platforms, public ones, private ones that companies have built themselves, but even, the jargon and terminology internal to the company and the domain, right? Do you have to learn all about how advertising technology works, or retail, or insurance, or whatever field that company might be in? And then even for that specific company, homegrown software or projects that have funny secret names or acronyms. So it's almost sort of 3 or 4 sets of jargon all at once.
Oh yeah,
I've
absolutely.
found.
Yeah, it's like if you were starting grad school in astrophysics, and then your university had its own specific jargon.
Yeah, so I also had that question, so I'm grateful Jeff asked it as well. I'm aware also that you have a set of slides that you've shared with the public of astronomy to data science. And so, of course, thank you for doing that for everyone. I'm wondering if you have anything that you've noticed that's quite different from when you transitioned to today. Like what have been the biggest changes that make it harder or easier for someone who wants to transition this year, for example?
I think one thing in favor of folks that want to transition is there's a lot more literature that's publicly available, whether it be the set of slides that I've worked on, or other people's Medium posts. There's a lot of anecdotal guides on how different people have navigated the transition themselves, and I think that's really encouraging. When I did it, there really wasn't that much out of testimonials from boot camp members, which you don't really hear until you've joined that boot camp. So I think there's like, and another thing is that it's becoming more and more normalized, right? Like leaving academia to go into like a private data science job or like a municipal data science job is pretty common now. It's like I think one of the major exits out of a PhD program. So in that sense, like it's, people aren't surprised when you do it. People can connect you to say, hey, so this other professor's student did the same thing a couple of years ago. Here's the contact with, and there's a lot there's a lot more communal knowledge now, I'd say. I'd say the thing that's more challenging today is again related to this barrier of entry, but also a little bit of a shift in what it means to be doing data science. I think when I was looking for my first data science job and for a couple of years afterward, it used to be that, hey, if you're a data scientist, you know some tabular machine learning models, you're able to run them, you're able to, do your simple kind of test, train, validate splits. You're able to do, A/B tests for statistical significance. You're able to kind of use these statistical tools, and then you kind of present your results. Here they are. That's really different now. I feel like there's a ton more focus these days for data scientists to be able to deploy their models into production. I mean, that's a jargony thing, but how do you write a model and then make sure that it integrates with your company's internal cloud system so that you're generating reports or you're integrating your results into an app in an automatic way? And that's a very different skill set. And especially at small companies, you have to wear both of those hats in addition to cleaning your data, in addition to kind of handling your team's data governance. Like there's like 4 or 5 hats that you have to wear, be from doing the actual model to doing some of the backend software engineering to make sure some of it's reasonably automated, to doing like the data engineering and data cleaning to make sure ensure that the data is trustworthy and it's clean. And I think there's more of a separation at roles at larger companies, but for like startups, medium-sized companies, small companies, like you have to wear a lot of those hats, and that can be really challenging.
Yeah, I totally agree, Taka, that like over the years, the what data science means or encompasses has grown, and along with that, the types of roles, the types of responsibilities, the types of skill sets that a quote unquote data scientist should have or could have for certain roles, even the titles themselves, right? I think when you and I made the transition, I don't think machine learning engineer was a title like that. Just I don't think I ever saw that until maybe 3, 4, 5 years ago. And so there's many flavors that I would consider, sort of data science related of different titles: business analyst, data analyst, or engineer, depending on, again, where you focus, where the skills are.
Analytics engineer even.
Yeah, that's right. That's right. My company has some analytics engineers as well that I work with. That's true.
Yeah.
And so, yeah, I think that has kind of grown. I mean, the joke I always love to tell is, if you ask 5 data scientists to define data science, you get 10 answers.
Yeah, it really comes down to like, I think initially, when folks were hiring data scientists, there was a little bit of hype behind it, right? There's this hype that, oh, machine learning, XGBoost, that's like winning all these Kaggle competitions. We want people that are able to do that. And then I think the realization has come, or like the thinking shift over the last few years, is like, you don't like the lift from having like a reasonable, sensible model that's very simple to having a very complicated one or very fancy one that uses the latest algorithms. That lift is usually not that large. Once you have any sort of model, even if it's like a simple tree model, the biggest lift after making that first model is usually in, okay, how are we going to integrate this model into our business processes? How are people going to see these results in the app? Or how is this going to affect what people are going to see in the app or the website or in our business kind of decision-making algorithms? And so I think where companies are looking for value has shifted from having the fanciest model to integrating that model into your business process. And that's why I think there's so much of a focus on machine learning engineering and analytics engineering now. It's not enough that you have people to generate these models and insights. Is that you either want those same people or a different team of people that can then integrate that into the rest of your company's technology.
All right, so I question about your first year or so as a data scientist. What sort of projects did you work on, if you're allowed to talk about that?
I think I can broadly say that I worked on TV rating predictions. I won't say how they were used, but I predicted TV ratings. Um, just, a fun project. It's like you get to think about pop culture or the kind of the behavioral cues that people take into watching TV, and how, say, streaming is affecting cable TV viewership, for example. So it was like a culturally interesting kind of psychology, like a mass psychology problem, and also like a really interesting quantitative one too. You have millions of people watching TV, but you also don't necessarily have direct visibility into what those millions of people are doing. You have to sample the data and then think about how that sampling might be biased. You have to think about how then you can predict that sample data. Um, that was really interesting. I got to learn. Um, you know, I wrote a lot of SQL in my first year. I still write a lot of SQL. Um, I got to think about a lot of different feature engineering approaches. I got to think about how do you then automate this model to run in production, so that clients and other business partners can see the results in the dashboard, say. So we had a yeah, had a lot of I learned a lot that first year. Um, I got to think about I got to learn about how people think about the business uses of data, how people how these ratings and the predictions factor into business processes and decisions. So yeah, it was very eye-opening. I made a lot of great connections professionally as well. It wasn't a case that's like, oh, some PhD came in, new guy on the job. No, people in general, I found every workplace that I've been a part of after academia to be very collaborative. People are very friendly. People are happy to have your insight. And then sometimes, people will communicate differently. Like they don't um, the way you talk about data or where you talk about results or the way you think about approaching and solving problems can be different at times from someone that's, say, coming from a STEM PhD as opposed to someone that has an MBA. So yeah, it was eye-opening in a lot of ways and overall an overwhelmingly positive experience.
So we've talked a lot about getting into the field, starting off first year. After that first year, let's get into, you've been doing this for a number of years now, Taka, career growth, leveling up. If you want to dive into sort of the management tracks versus the IC, the individual contributor tracks. Most academics I know start off on that sort of IC track. They're data scientists, they're doing their own thing. They might be at a somewhat senior level, depending on background and the company. But rarely are people moving directly from academia into managing a team. But pretty quickly, both of us, in fact, moved into the managerial world because we had groups and we mentored. So yeah, sort of how did you make that move and sort of what did you experience in those first, let's say, 2 or 3 years 2 to 4 maybe?
Yeah. So one thing about IC or individual contributor roles and management roles is that I'll say a couple of things. At least early on, if you're like, say, manager, senior manager, director level, and even beyond that, if you're like a CTO at a small startup or even a CTO at a large company, even if you want to code, you usually can. It's like, now, will you have time for it? That's another question. But if it takes you doing some code or grappling with some um, modeling problems or data analysis to keep you sane, like you can carve out time for that. Like you will always like no one's going to say no to a senior person helping out with some code or code review or algorithmic development. That's all good. And I think a lot of times when you're kind of entering that managerial role, I think the key question is, what's that split? Is it 95% management and strategy and 5% coding, or is it 60% coding and 40% kind of helping others stay on track and align their work with the team's objectives? And then another thing I'll say about the individual contributor versus manager track is this is something that dawned on me earlier this year in the last few months or so. Um, I think the key question to ask if you're not sure which one you want to do is what kind of problems do you want to keep you up at night? Now, if you're an individual contributor, chances are when you're in the weeds on a problem or a project, you're going to be, you're going to dream about that algorithm. You're going to dream about that, bug in your code, and you might lose sleep over it. Just as you would doing a PhD or postdoc, like these problems keep you up at night, and it's a part of. As much as we all love our work-life balance, it's like there is, you're really into your job or you're working hard at it if it's following you to your dreams. It's not ideal, right? It's like none of us's favorite thing, but it will happen at some point. And so if you're an individual contributor, you're going to be losing sleep over technical details about the technical execution of your work. If you are a manager or a strategy person, then those are the problems that are going to keep you awake at night. Um, thinking about the career progress of one of your direct reports, or thinking about how you're going to navigate your team or your company's data strategy. Like those are the things that you're going to lose sleep over. And I think an important question to ask yourself is, well, if you're going to lose sleep over it, which one is it going to be? And whatever, if you're more comfortable with one of those things, I think that there's a very good chance that that's the right career track for you. So for myself, stepping into a manager role did not come naturally to me. And I was, in fact, very averse to it. I did not feel comfortable managing people or leading people. It took a long time for me to kind of accept that that was something that I could handle, that I even wanted to do. I think it came after I was in the role kind of unofficially. So before I hired people or before I took on direct reports, I found myself doing it in an unofficial capacity in terms of getting coffee with a coworker, talking to them about the frustrations related today, or their questions about career paths. What do you want to do at this company? What is that team even doing? What is our team even doing? How is my project going to help? Or how do I get my manager to see that I'm doing this? All those kinds of things that crop up, and these questions are the same kinds of things that might come up in an academic context too. How do you navigate relationships? How do you get your advisor to notice how hard you're working? How do you get how do you deal with difficult teammates or difficult advisors / managers? And then I found myself increasingly vocal in strategy meetings where we were trying to decide on the right path forward, or the right way to build a product. And so that combination of things where I found myself getting positive feedback for I didn't think of it as mentoring then, but for being a thought partner to different people. And then being a vocal presence in the boardroom, basically a combination of, guiding individuals and their kind of their questions, their angst, their aspirations, and also then saying, hey, if we built the project this way, as one of the options we're considering, we're going to have XYZ problems. We could prevent that entirely if we chose this simpler approach. Or conversely, hey, if we take this simpler approach, this aspect of the project is going to bite us in the ass someday. So we better have a strategy for mitigating that. And the latter part, at least, I think is another skill set that comes from being in academia. It's like, I think one of the things that we appreciate, or we learn to appreciate in academia is like, you hear colloquiums about all sorts of different projects across the field, all sorts of different observational techniques, all sorts of different theoretical inferences or uh, data crunching approaches. And so by the end of having done 2 postdocs, I could follow along to a lot of these projects as people were just describing how they went about them. And then a lot of new questions that would crop up scientifically, you know, you can start thinking about, oh, right, in order to accomplish this scientific goal, you have to measure X, Y, and Z. And I can tell that Y is going to be really tricky. And it's like being able to kind of reason all that in the first like 15 minutes that you're hearing about a problem is really useful in the boardroom as well.
So I've got a question now about today.
Mhm.
In your current role, are
Mhm.
what sort of things are you excited about doing, either projects or things that you're learning about?
Yeah, we have a lot of projects on our team. So I work for uh, a prop tech company. So this is technology and real estate. Um, there are a couple of things that have me, several things actually, that have me really excited about the job. Right now, the team is about a dozen people. Um, I'm really excited about the team that we built. I'm really excited to come to work every day and, or work from home every day and see the progress that's been made. I'm, eager for the new bugs and challenges that pop up. And it's fun to collaborate on these problems. And then on the business end, I'm really fortunate to be part of a team that's integrated very deeply in the company strategy. I think one of the questions that will always crop up when you're considering data roles is the team's work central to the company's business, or is it something, is it more of a supplementary function? Um, our entire team presents to a senior executive groups that includes all of the founders and several heads of department every 2 weeks, and it's an hour-long meeting, and we, go high level to very low level, from kind of like, hey, here's a reminder of what this project is aiming to accomplish and kind of the business impact that we want it to have. And then here are the updates concerning improvements in the algorithm, different kinds of data we're considering, and the deployment process. And so it's a really cool opportunity to share our progress with the leadership and get their feedback on prioritization and usability and all of these things. And then finally, on the technological side, um, I'm excited that we're at this, I hate the term inflection point because it gets overused, but it is kind of like a pivotal juncture in the way we deal with data. And I think this is especially true for businesses like my companies, where the data is historically very analog. So if you work for like e-commerce, if you work for a company that has a web app, if you work for a streaming service, you have a ton of digital data in kind of natively tabular format, and it's relatively straightforward to build, regression or classification models or clustering models because everything's in tables already. In real estate, that's not the case because the source of truth in real estate is a paper document that people sign with, notary stamps, right? And then that gets recorded by county clerks, right? All of the different counties in the United States record these real estate transactions as a matter of public record. So our source of truth is those documents. Our source of truth is insurance policies and documents. Our source of truth is appraisals, uh, articles of incorporation. Like just imagine stacks and stacks and stacks of PDFs, and that's our source of truth. And the reason why this is exciting is because I think we're, for the first time, able to process these unstructured pieces of data that we as a society weren't able to 5 years ago. We just didn't have the technology. Now we have optical character recognition that's like pretty simple. Read the text off of a PDF document. It's pretty simple to locate and isolate the tables and images in a document and then run those through their own sets of algorithms. And then with large language models and generative AI, you can ask an AI to parse what's going on in this document. Does this document contain X? Can you tell which people did Y in this document? Now, this is very much like a raw tool. It's a very new tool, and we have to be really careful not to cut ourselves with it. It's, as we've all probably heard, AI can hallucinate. It can confidently tell us false answers. So we have to be very, very careful about not getting the wrong information. But I'm really excited that we're at a place technologically where we can implement these new kinds of, I hesitate, or I make myself cringe with the term AI, but we can use these new kinds of algorithms to actually attempt to solve business problems with them. And that to me is really innovative and really fun. I can honestly say the work that our team is doing is very few real estate companies are trying to do this. Very few companies are truly using AI at scale. So I think that's a lot of fun too. And then another part of it is images, right? Property images, images of rooms, Google Street View images, satellite images. Being able to use computer vision in this context is also a lot of fun. So, I didn't think, and if you had told me 6 years ago as I was leaving academia that, oh yeah, you're going to be leading a team at a company, you're going to be an executive, and you're going to be working with AI algorithms and computer vision, I could not have imagined that, but here we are.
Awesome. So it seems like, imagining 6 years ahead of time is pretty difficult. And so
it's a really hard problem, right? And it's like, and now I'm thinking about I don't know, faculty application statements or postdoc statements. It's like, please describe your 5-year academic plan or research plan. It's like, I don't know. It just seems like a very weird thing to have to do. It's like, because how many people's 5-year research plans actually come to fruition or unfold in the way they do? Maybe they do. I don't know. But it's like, in my case, it was completely unexpected.
Yeah. So in light of that, it's still fun to talk about. Do you have any predictions for 5 years from now in the data science field? How that landscape might look?
I think there's going to be increasingly a push toward this deployment and implementation skill set. So whether it be ML ops or ML engineering, like having that skill set to be able to take the fruits of either your own or someone else's piece of code, whether it be a really simple algorithm or a really fancy one, and then integrating it with the rest of your company's technology is going to become a core competence. And then another prediction I have is we're going to be doing a lot of wrangling with AI over the next decade. And basically getting a generative AI algorithm to do what you want it to do without giving you crap is going to be a really nuanced skill set. And right now, so they call this prompt engineering. It's a term that really didn't exist a year ago. But now, right, if you work in data science, if you work in AI, everyone's talking about prompt engineering, or at least everyone knows what it is. And that's a new thing. But I have a feeling that that's going to be an increased focus, if not for all data scientists, then at least for teams. It's like you need someone in your team that can prompt engineer so that you can ask a large language model to produce the outputs that you want it to. I do think that that's going to be the next like big treasure hoard, or in terms of like unlocking value that people are going to attempt. I'm not sure how successful like companies in general will be, but there's a lot of unstructured data. There's like, think about, right, customer service chatbots or images or videos if you're a streaming service, right? It's like there's all sorts of data that like historically has been outside of this tabular realm. And I think using generative AI and other methods to summarize this data, to make conclusions about this data, to be able to answer questions about this data is going to be increasingly tempting for companies to do. So at least I'm not sure if it will be around in 10 years, but I think the next few years is going to be a real test to see if is this technology ready. And if it is, people are going to start using it a lot. We're going to see it everywhere. And if it's not, then we'll probably see it kind of plateau for a little bit, right? So is this going to be, the next self-driving car claim, or is this going to be, the World Wide Web? I'm not sure yet.
So because you have also a background in astrophysics, I'm wondering if what your perspective is on the developments in data science and machine learning, what role they can play in the field of astrophysics that might be different going forward in the next few years than when you were in the field.
That's a good question. I think a lot of the techniques around handling large amounts of data, lots of techniques around interpreting like image data, recognizing features in images and 3D maps and things like that. I think the ability to parse through that data in ways other than, hey, look for a peak. I think there's a ton of use cases there in terms of like computer vision to look for features in images, just mass data crunching methods for, data from like LSST and other massive data sets. I think there's going to be increasingly like a more of a regular use case for things like random forest algorithms to do regressions and curve fits as opposed to using a fitting formula. I think it's going to increasingly shift from, hey, does this equation or does this mathematical formulation make sense physically? Is it well physically motivated? Does it reflect the realities of the universe and physical law that we expect? It's going to increasingly shift from that to, hey, are the features in your model, are the key steps in your model physically intuitive? Are you taking advantage of physics or the nature of astronomical objects and phenomena in the way that you've constructed your model, or is your model just looking at random things? I think that's going to be, for me, that's a huge difference between having a model that looks at really kind of randomish, unmotivated things and look for patterns that way, or having the model look at the data and slice the data and use the data in a way that's already kind of guided in a physical way.
One last question, Taka, that we'd like to close with is, if you could give advice to yourself back when you were starting out in data science, or to astro and physics academics looking to get into data science, sort of your 1 to 2 sentences of best pearl of wisdom.
I would say find your people. I think find people that are willing to advocate for you, find people that will give you candid advice, um, find people that take an interest in your career and in your projects, people who will help navigate your career path, career trajectory, as well as um, workplace relationships. I think that like there's an opportunity to do that, at least in my experience in data science and just kind of the broader job market in general, that I didn't really know was possible in academia. Like once you find people either in your workplace or as professional connections, um, that that can be your thought partners, um, that's going to accelerate your growth. It's going to expand your horizons. It's going to give you so much breadth as like what else is going on in this field outside your own company, outside your own team. It's just such a big difference in what you can know and what you can accomplish. And that can be really hard to imagine, especially if you're a PhD student and your kind of universe is your department and maybe the couple of outside collaborators you have. I mean, that's not always the case, but that's often the setup. And when that universe is like 20 people, it's really hard to envision. It's like, oh, who's going to be my person? Who's going to be my advocate? I mean, you might have a colleague, you might have a mentor or a professor, maybe even you're lucky to have an advisor that's like that, that can help kind of level up your career. But in once you step out into a company, like your company might have 300 people, it might have 10,000 people, right? There might be meetups about data science where 50 different people get together in your city, every other week. Find who those people are, and then yeah, that's that's going to be such a difference maker, and it's going to both help you long term and also kind of sustain you in the short term, because there's going to be a lot of stress. There's going to be, I think we all get more job rejections than job offers. Like, it's there's a lot to navigate. There's a lot to learn. There's going to be a lot of stress over those first few years. And there's going to be stress beyond those first few years too. So having a network that can support you, that you can vent with, that you can grow with, I think is going to be hugely important.
That's great. Thank you so much.
Thank you.
A huge thank you to our guest, Taka Tanaka, for sharing his insights and experiences. Thank you all for tuning into this episode, and feel free to subscribe in order to find out when we release future episodes.